Well, hello there, everyone. This is KP the Math G. This problem's been sitting up here for at least a couple of days, and it's time to address this. I finally got a chance to, um, well, come in here and record something. I'm always busy. Um, I think my wife keeps me busy too, but I do a few things on my own, but by and large, my wife has a to-do list longer than a child's Christmas list, if you know what I mean. Okay, anyway, enough of the dry jokes. We'll get started. We're talking about optimization, and you know, when I taught calculus a few years back, this was one area that I had to really dive into and learn how to teach this. It has to do with a maximum or a minimum. And so you just have to realize that when you're teaching this or when you're trying to learn it. So let's dive in. I'm probably going to do three parts to this. Okay, at least two for sure. One is where you get a maximum size, and one is where you get a minimum size, and of course, you know, in one of my examples, on the minimum part of it, I'm trying to cut cost. I'm going to cut cost to a minimum. Here I'm trying to make a box, and I want the maximum size. Okay, so let's talk about this box. It says, I hope you can read this. If not, I'll try to read it to you, but I hope you can see this well enough. It says that a square sheet, so it's a square sheet of 20 inches on a side. Okay, actually on each side is to make an open top box by cutting a small square of 10 from each corner and bending up the sides. Okay, here's kind of the picture here. Alright, so we're trying to cut the corners out. This is not drawn to scale. My wife saw this yesterday and said that's really a square, but you know, I always say that I don't draw things to scale. And so sometimes it looks like it is, but most of the time things don't look to scale anyway. So anyhow, be that as it may, this is supposed to be a square, and these corners are cut out. Okay, and you notice that each side is 20 inches long. It's a sheet of 10. Alright, and so these sides are going to be bent upward. Now the question is, how large of a square should be cut from each corner to yield the largest or the greatest volume? Alright, so we're wanting to get the greatest amount of volume here. Okay. Let me just kind of, before we're setting this up, this is a volume, length times width times height. And one of the things that you probably know, that if this is a square, what do you know about length and width? Yeah, that's right. It could be that the length is the same as the width is the same as the length. You could say, actually, L squared H or W squared H if you wanted to do it that way. In this case, we're dealing with X, so we're going to have everything in terms of X here in this problem. Well, let's go ahead and start. Let's see now. Just a little idea here. We see that the whole length is 20 inches. Oh my, okay. This whole length is 20. But there's going to be an X amount cut off here, alright, and an X amount cut off here. And so when you cut this out, this is not going to be 20 inches. It's going to be from here to here. So what is that? If it's not 20 inches, you're cutting out an X amount over here on this side and an X amount over here on this side. So that's one X and another X. That's two X's that you're cutting out. So in all, yeah, that's right. If you said 20 minus 2X right here, you are absolutely right. So this side here, this being a square, that makes this easy. This is 20 minus 2X as well. And we know that the height, h, is going to be x, because once it's bent up, it's x amount, or x inches. Okay? Alright, so that's what we have. Length, width, and height is x. So here's how it's normally set up. Since we're dealing with length and width, both of these are 20 minus 2x, okay, times 20 minus 2x, and then of course times the height, and there it is. So we're going to write this on the other side. I just wanted to at least I wanted to do two problems, but there's no way I can do two problems, two separate problems, as much work that we have to do here. So I'm just going to flip it over and we'll just do one problem at a time. Alright, I'm thinking about doing three problems, but I may just do two. I'll just have to wait and see. And again, it doesn't matter. I just want to show you, to the best of my knowledge, how to deal with optimization problems, okay? Alright, let's go ahead. I want to flip this over now. Okay. Alright, so remember 20 minus 2x, 20 minus 2x times x. Okay, here we go. We're going to flip this over. Okay, there it is. Alright, so let's get up here. So v at x actually is 20 minus 2x times 20 minus 2x times x. Now that's your volume. Let's go ahead and multiply all of this. So we're going to have a little bit of work to do to get it the way we want it before we take v prime. Before we do this, why would we want to take v prime in the first place? That, you want to know why you want to do this. Well, you're looking for, let's say if we're looking for a max, it's kind of like a curve here, y'all, and I want the maximum here. So that means that this slope, remember this slope of the tangent line, must be equal to 0. The max or the min, either one, if you're looking for a max or a min, you got to say that whatever v prime in this particular problem is equal to 0. Alright, so keep that in mind. Alright, so there we go. So we're just kind of rewriting v right now. Let's multiply this out. 20 times 20 is 400. Okay. 20 times 2 is 40. 40, and then another minus 40 is minus 80. Minus 80x. 2 times 2 is 4. 20 times 2 is 40. 40. A negative 40 and a negative 40 is a negative 80. Negative times negative is positive here. 2 times 2 is 4. X times x is x squared. It's imperative that we get this correct. And remember, we still got an x out here. So now let's write it one more time. V prime at x is equal to, okay, now it's 400 x minus 80x squared plus 4x cubed. Okay, and that's basically where we are with this. And yeah, I did the problem a few days back, and I just wanted to double check, but this is good here. Now, whoa, that's not v prime, it's just del v. Sorry about that. That we're not looking for v prime just yet. We do remember, oh yeah, that's another thing we need to keep in mind. We want to see where the volume, well, doesn't really, if it exists, if there is a zero volume. We know that if x is 0, then whatever this times 0 equals 0. So that we know that x cannot be 0. But x lies between 0 and then now some other number. So we don't want this, either one of these two, which are the same anyway. We don't want these to be 0 either. So we go with this, 20 minus 2x. Let's say, well, what happens if it is 0? I'm going to bring minus 2x over here. That's going to be positive 2x. So 2x equals 20. So we're saying then that really, if we plug 10 in this, that would be 0 also. So if x is 10, this whole thing is 0. If you picture in your mind 20 minus 2 times 10, 2 times 10 is 20, and 20 minus 20 is 0. And 0 times 0 times, well, in this case, 10. 0 times 0 times 10 is still 0. But we know that our limitations have to be between 0 and 10. I cannot make them equal because I don't want them to be equal, but we do know that x has to be between 0 and 10. Okay, that is something I had to learn really good there to learn where the stipulations are. Okay, there's a limit here where x can be. All right, let's go ahead now. V prime. V prime at x, easy enough. This is 400 minus 2 times 8 is 16, so 2 times 80 is 160 x plus, now this is 4 times 3, 3 times 4 is 12, 12 x squared. Let's rewrite it and set it equal to 0. Okay, so let's see, this is now 12 x squared minus 160x plus 400. Now we're saying v prime is equal to 0 because that's where I'm looking for that maximum. See, that's what I'm looking for here. Alright, we can factor this as is, but I think if we factored out a 4, I think we can factor out 4 and make this a little easier. So if I always do this, I divide by 4 like that. I can do that, and then that's going to make this be 3x squared minus, let's see, 4 times 4 is 16, so 40x, and then plus 100 equals to 0. And then after factoring this, I found that we can do this now. Okay, so now I can factor this. This is 3x, and not all of these will factor. You may have to use the quadratic formula. You may have to complete the square. Every which way is more comfortable for you, but boy oh boy, if it can be factored, I like to do that. Minus times a minus is a plus. I need minuses here because I need that middle term, but a minus times a minus, I need that last term to be positive. So now it does work with 10. So now, here we go, right here. Alright, so now we've got it up here. I think I can put it here now. 3x minus 10 equals 0. Well, if I add 10 to both sides, I'm down to 3x equals 10. And then when I divide by 3, x equals 10 over 3. If you want to make an approximation, that's about 3 and 1. Well, it's exactly 3 and 1/3. 3 times 3 is 9 and 1 is 10. 1 more third is 0.3333, whatever. Okay, so anyway, there's that one. Or we have x minus 10 equals to 0. If I add this to both sides, x equals 10. But in my estimation here, I'm always knocking something over. I'm in a small room, please bear with me. X cannot be 10, so we cannot use that, because that is what we said would make this thing equal to 0. Alright, so we know we cannot use that part. Alright, this is out. This is the only one that's between 0 and 10. Alright, so let's try it and see what, because we know that our original problem, if we back up just a little bit, I want to flip this back over. We had, oh, here it is right here. Well, let's look at that picture again. Let's look at the picture again. Okay, what were we looking for? We want to consider what we're looking for. If we're looking for the volume, all you have to do is plug in the 10 over 3 right here, here, and here. You got the volume. If you want the dimensions, you just need to do. Well, if you just want the dimensions, you can just simply plug in 10 over 3, and you have the length and the width. Okay, and then if you, well, it just depends on what is being asked for. In this case, it says how large of a square should be cut. So we're looking for the value of x, which we already have. All right, that's all we're looking for. So we found that to be x is 10 over 3. So actually, when we talk about this picture right here, all right, right here, when we talk about this picture, each of these x's are 10 over 3. Alright, and this x as well. To get the maximum volume, you cut out 10/3 of an inch. Okay, and again right here, same thing. Alright, right there, 10/3, 10/3, and then right here, 10/3 and 10/3. And this is going to give me, or give us, the maximum volume. Okay, if they ask, if what is asked for is the volume, you simply plug this into all three of these, and you have your volume. I want to erase this because there's so much here in the way. I don't like a crowded board. Okay. Alright, there it is if you want to find the volume. Alright, if you want to find the length and the width, you just simply plug that in one time, and you know that whatever you get for this one, you get for this one as well. Okay. Alright, so there it is. That's what we were looking for here. And by the way, we are talking about inches, so this would be x equals 10/3, 10 over 3 inches. Okay. Alright, so there it is right there. Once again, this is, just remember that you have to learn how to set this up 20 minus the 2x's here is 1 length here, okay? And then 20 minus 2x, since it's a square, and then the height is just x. Alright, there it is, right there. Alright, the height is x right there. Alright, and so then set it up. Once you get it down to here, then you can just start finding the derivative, because you're looking for that maximum, okay, amount right here that you can cut out. Okay, so we want the most volume out of this box that's being folded up here on the corners. Okay, alright, so again, this is KP the Math G. Hoping that, well, I hope that you have learned something from this, that you understand how to find the well, restrictions here. Some problems don't ask for that, but most problems do. So you need to find those restrictions and then be able to set this up and then go ahead with that. Alright, KP the Math G signing off. Have a great day.